Hello, and in this video I'm going to look at using sec, cosec and cot and how to solve equations and how to take things that are grotty like this and combine our knowledge of what cosec, sec and cot mean in order to cancel things down and make them solvable. So this looks like a really nasty question to start off with, but actually once you look at it with the idea of what these things are, then everything starts cancelling, and what it should do is turn into something nice like cos cubed. So anyway, let's have a look. So we've got to remember that sec is 1 over cos, cot is 1 over tan, and cosec is 1 over sine. Now I don't write the I haven't even written equals there. I don't write the x on, which is a very bad habit of mine, or the theta in this case, so apologies for that. But obviously you need to write the angles down as well, because it doesn't make sense. That's like saying, you know, times equals divide or something like that. That it's completely meaningless if you don't have the angle there. So apologies if I go back into old habits and forget those. Okay, so let's rewrite what we've got here as a big old fraction. So cot is 1 over tan theta times cosec is 1 over sine, so 1 over sine theta. And then this is divided by 1 over cos squared theta plus 1 over sine squared theta. Okay, and we're not going to use this bit yet, the proof bit. We're going to say, okay, well, let's pretend we don't know that. Let's see if we can process this, turn it into this one. So, okay, well, first of all, we know that tan theta is sine theta over cos theta. So we can replace this with sine over cos. I think that's a good idea. So we've got cos there, cos theta, and we've got sine theta underneath. And we can just put these two together into one fraction. Cos times 1 is just cos over sine theta. Squared, sorry, sine squared theta, because we're timesing them together. The bottom one, we're adding them together, so we need a common denominator, and if we times them together, sine squared theta, cos squared theta, then we've got to make equivalent fractions. So we times this one by sine, we times this one by cos, so we get sine squared theta plus cos squared theta. Now I hope you remember that sine squared theta plus cos squared theta equals 1. And you get that from doing Pythagoras, I believe. Pretty sure, anyway. Anyway, that's an identity that you ought to remember. So we can just replace that whole thing with, we can replace that whole thing with 1. And now we've got a fraction divided by a fraction. We'll do good old-fashioned keep, change, flip. So keep the first fraction, cos theta over sine squared theta. Change that divide to a times and flip this one around, sine squared theta cos squared theta all over 1. Well, we don't need that, so get rid of that one. And now we can do some cancelling and say, look, sine squared divided by sine squared is going to go, and cos times cos squared equals cos cubed theta, which is what they wanted. Perfect. So it's taken all the screen up, but there we are, no worries. We have proved by just substituting these in, that was the bit about sec, cosec and cot, was just replacing them with sines and coses, and after that it was just rearranging, it was just messing around, there was nothing to do with it. And I think that's the point, because with sec, cosec and cot, there's no buttons on the calculator, so you can't process them on the calculator. You have to turn them back into sines and coses in order to solve what you're doing. So now we've solved all that, proved all that, we can now do part B of the question. Hang on, let me just get the right tool up to get rid of all the annotations, and that as well. Okay, so now, hence explain why the equation has no solutions. Well, we know that we can, this fraction is just the same here, so we can rewrite that as cos cubed theta equals 8. Okay, well, if cos cubed theta equals 8, then cos theta is the cube root of 8, and that would mean that, cos theta would equal 2, and it can't. We know that on the cos graph, it oscillates between 1 and -1, so it can't equal 2. That's going to give us a maths error, or indeed no solutions in this case. There's no situation where you can get a value of theta which will give you that value of cos theta. Okay, so what if you've got what looks like a much more straightforward question, which is just I have cosec of x equals a value and then find the answers in that range? Well, yes, we can do that, but we can't do it straight off with the cosec unless your calculator happens to have buttons for that. We need to change this. So we can say that if cosec equals 2.5, then 1 over sine x equals 2.5, and then just rearrange this to say that sine x equals 1 over 2.5. Times that up, divide that down. And now we can solve this. We can solve this quite easily. We just do inverse sine. So x is going to equal shift sine 1 divided by 2.5. And we get the answer of 23.6. We'll round it up. But of course, we're not going to leave it like that because it says giving answers in the range 0 to 360. So we need to do a cast diagram, or some people call it all students talk crap. We've got, we turned it into sine and we had a positive value. So that is giving us the right answer there. And so the other answer where sine is positive will be this one, which is 180 minus 23.6, which I can't bother to work out, but you would work that out and write down the answer there. And there's no coefficients or anything, so there'll just be those two answers, and then we're good. Okay, so what about some other questions? Here we've got something with sec squared and tan, and it's probably not obvious that we can solve this just by throwing in the trigonometry. So if we try it, I mean, why not? We'd get 3 over cos squared x plus normal tan minus 5 equals 0. I mean, you know, what can we do with that? We can turn the cos squared into sine squared using our sine squared x plus cos squared x equals 1, but that's about it. There's nothing really we can do about it other than that. Well, there are some things we can do, but we're going to need to make some new identities. So, in fact, I shouldn't have rubbed that out at all, but let's start at the top and have more space. If we start off with sine squared x plus cos squared x equals 1, let's divide this whole thing through by sine squared x. We're going to get sine squared x over sine squared x is 1, plus cos squared x over sine squared x is going to be cot squared x, because of course cos over sine is 1 over tan, yeah, because tan is sine over cos, and that's cot, and it's squared because we've got squared. And this equals 1 over sine, which is cosec x. And if we divided everything through by cos squared, then we'd get sine squared over cos squared, which is normal tan squared x, plus cos squared divided by cos squared is 1, and this equals 1 over cos squared, which is sec squared x. So we've got these two identities, which I think we can use here. And indeed, we're going to use this one here. That's a plus. Look at that. That's terrible. Plus there. We're going to use this one, sec squared. We've got 3 sec squared here. You've got to watch your pronunciation on these. So we're going to substitute this thing in instead. So 3 bracket tan squared x plus 1 plus tan x minus 5 equals 0. And hopefully what you can see there is that this is a quadratic with tan in it. Okay, we've got 3 tan squared x plus tan x. We've got 3 minus 5, so minus 2 equals 0. And now we can solve this as a quadratic first and then trigonometry. So if we write this as 3u squared plus u minus 2, just to do the quadratic first, I wonder if we can factorize it. it will be 3u and a u, and it'll be a 1 and a 2, and we've got to make 1. So 3 times 1 and 2 times 1, that should work. And if we want positive 1, we need positive 3 minus 2. Okay, so that's great. So we've got that u equals minus 1, and that u equals 2/3, bringing them out of the brackets, which obviously means that tan x equals these things as well. So now we can do inverse tan of this, and we can get a couple of answers from that. We'll need to use our cast diagram again. So if we do shift tan of minus 1, we're going to get minus 45. Well, we're supposed to be in radians, okay? So that's fine. We'll just put it in radians and do it like that. Or if you haven't done radians, then don't worry, it's just a different way of measuring angles. So you can either say, well, minus 45 degrees down here isn't within our range of 0 to 2 pi or 0 to 360, but I can represent it as coming all the way around here to 45 less than that, or pi over 4 less than that, so 2 pi minus pi over 4. And the other answer will be, no, maybe not that one. If all students talk crap, this is giving a negative answer, so we want this one here. So we're going to have 45 degrees or pi over 4 less than that, so it's going to be that angle there. That gives you 2 answers for that one. And this one, you do the same thing. Tan to the minus 1 of 2/3 is 33.7. And that's giving a positive answer, so that's 33.7 degrees there. And the other place that it gives a positive answer is in the tan section, so that's going to be 180 plus 33.7. If you're not very good at doing the cast diagrams, I think that's another video. I just thought I'd complete that just to sort of show you that all the way through. But the key thing for using Cosec, Sec, and Cot is knowing these variations of this identity, so that you can think, right, actually I can replace that, get it all in tan, and then I can set it up as a quadratic, and then set it up as a finding 4 answers in this case using the cast diagram. Okay, last example, and then I'll best turn the video off. It's getting particularly long, this one, so let's get rid of all of this. And we won't do the whole thing on this one, we'll just set it up until it's in the quadratic. So looking at this, cot squared, so we could rearrange this and get it and say that cot squared is cosec minus 1. That would be absolutely fine. The other thing we could do is we could just replace that, and we won't end up with a quadratic in the same way. You know what, I think probably I'm going to I was going to say cot squared. Let's say that cot squared x equals cosec x minus 1, and then just replace that and say, so cosec x minus 1 plus 2 cosec x minus 7 equals 0, which gives us 3 cosec x minus 1 and minus 7 is minus 8, which equals positive 8. So let's move the 3 down. Cosec x is 1 over sine. So if 1 over sine x equals 8 over 3, then sine x equals 3 over 8. The only thing I'm slightly worried about is that if I'd have done it the other way, I'd have got cot squared equals whatever. You know, you'd have just put them together and done the same thing, got some fraction. And then when I worked out what the x value was, because it's squared, I'd have got plus or minus, and I'd potentially have got 4 answers. So there is a small chance that because of that substitution of getting rid of the squared, that this is only going to give me 2 out of 4 answers. So it's possible that it's a good idea to try that the other way and replace this cosec and say cot squared x plus 2 bracket 1 plus cot squared x, that's squared, minus 7 equals 0, do that, you're going to end up with a load of cot squareds, and then rearrange and square root, and then solve the tan. And you might find that there's 4 answers. It might be magical and cancel out in some way, but I think actually it's probably best to do it that way and just double check that that's not going to give you more answers. If you're not sure, when you've got 2 or 4 answers at the end, if you do this and you do get 4 separate answers, then just substitute them in. Just, write this out in the calculator, 1 over tan squared of that number plus 2 over cos of that number minus 7. If the calculator says 0 for all of them, great. If it only says 0 for 2 of them, then you know that the other 2 weren't supposed to be solutions. But I think I'll leave that one for you to have a play with, and you can let me know how you get on in the comments down below. The key thing is knowing what sec, cosec and cot are and swapping them in and out. So when you have something like this, you just replace it with 1 over sine, rearrange and solve. And if you've got something grotty looking that you know these 2 variations on this trigonometric identity, you don't have to remember. If you remember this one, you just remember how you convert it. Just divide all by sine or all by cos and write them out in the exam, and then you can use those to mush it into something that is solvable. Okay, pop something down in the comments if you have something to say. Otherwise, ta-ra for now.